robots. One shoots out fireworks, and one is supposed to help make fireworks without having any humans make the fireworks because
It's dangerous.
it's dangerous.
Hi, my name is Cole.
Do you want to explain the parts? Or just explain the purpose of the firework one? How it relates to the theme?
Yeah, the theme was fireworks, so we made kind of can move forward and backwards. It can shoot off small balls. It has a sparkler, and it has a catapult.
Hi, I'm Matthew, and for the robot's parts, some of the parts were either static, dynamic, or electronics, and some of the dynamic parts were, and dynamic is something that moves. Like this was dynamic, the sparkler, the balls were dynamic, and the wheels, the treads were, the treads and the wheels and the arm were, and the catapult were both dynamic.
Some of the static parts, which means they didn't move, were the beams, the pegs, and the bushings and the fans.
Some of the electronic parts were the motors, obviously. This motor over here is different from these motors because these kind of have both sides and they turn like this, and that one is just kind of a straightforward motor. The wires were electronic parts. The EV3s were electronic parts. The sensors also, there's a light sensor, which is also just a normal light, an ultrasonic sensor, and a couple touch sensors.
We learned that sodium explodes in water and how to program an EV3, or at least that's what I learned.
I learned that when elements are elements are burned, they make different colors of flames, and so sodium would make orange when it's burned, and copper would make green, and that's what is used for the colors of fireworks when they explode.
It's okay.
I learned kind of how to build a robot and kind of to arrange the motors in certain ways so that they can carry out more purposes than just one purpose. And also, different elements will burn at different colors, but the more heat there is, some elements will actually change the color of their burn.
Our program has, we use sound effects and music to enhance our performance and make it more like an actual 4th of July performance. And the catapult is kind of like the grand finale.
For this robot, the programs were this motor, which is the same as that motor here. That mixes it, and we just made that for a couple rotations. And a rotation is like how the motor goes, or like a complete how it goes around. And for this one, we had to be very careful with the programming because one rotation was too much. So we would have to put it to 0.4 of a rotation.
Yeah, so like he was saying, the arm, it also, it wouldn't move back. Really annoying.
Cole, can you explain why we would make a mixing robot for the team?
So that it's kind of so a second robot was to mix up fireworks, make fireworks, just and kind of to make sure that humans weren't in danger while they're making fireworks. And a couple other parts were the sparkler just kind of goes like this. Except faster. The ball shooters, when this rotates, it pushes an axle which pushes on the ball, which builds up tension and then shoots. The catapult just works like a catapult. Launches it up into the air. Yeah, we'll run our robots. Right?
7, 6, 5, 4, 3, 2, 1. Let go.
One of the days over. It's a long song.
It really is.
I'll be ready.
I think it's aimed at you.
It's about
Catapult.
Mm-hmm.
I think it's gonna hit Mom.
It
Never
doesn't go
was.
too far. See?
Oh.
It
Yeah.
barely goes anywhere.
I thought it was aimed right at you. Me too. I was ready. I was gonna.
Now we're going to run our mixing robot.
Get everything away because it tends to like to crush things. Wait.
Is ready?
Mixing.
Sometimes.
Yeah, that's a problem.
Yeah.
Sometimes it gets just stuck.
Wait,
a
I think I'm landing on the floor. Leaves behind parts everywhere.
We also added a few displays.
Yeah.
There was like an arrow and a stop.
Yeah, there's a stop sign on the TV screen.
Good job, guys.
Are there any questions?
Yeah. Why are there 2 L beams on the back?
Oh, those were to balance it out because this end was a little too heavy, this end was a little too light, so it would tip over.
Yeah.
Even if
And this
it
would all fall out.
Yeah, even if it made a little friction, it wouldn't be like the entire thing tipping over and all the little parts escaping.
Well, why couldn't you just put wheels in?
There was no room for another.
Yeah.
And yeah, that's really good. Yes.
What was the toughest part to program?
Probably the arm. 'Cause
Yeah.
We couldn't get it to go back.
It just kept going like this, and then it got stuck somehow right here. And then finally we got it to go like that.
And for the other one, it was making the music in sync with the
You mean the countdown?
countdown in sync with the actual start of it. Had a few minor difficulties.
Yeah. What were the actual minor difficulties?
Major difficulties. We actually thought it would go 1 second. Okay, and the countdown, the actual numbers would actually just go 1 second, so we had to add in
Yeah,
building
'cause-
blocks.
Yeah, we had added a weight box, and you notice at the end the countdown is kind of, it doesn't take as long. It's because we had to put like the weights were only like half as long at the end, the last 3.
Good job, guys.